Okay, so we got our three equations, and remember uppercase, lowercase. Lowercase is your sides, uppercase is your angles. You don't have to have these memorized, but should you ever have to memorize them, the thing that I remember is I remember the form, and I remember that if it starts with A, it ends with A. If it starts with B, it ends with B. If it starts with C, it ends with C. And then everything else in between are your other two letters. In general, if you're looking to solve for a variable, if you are looking to solve for either side A or angle A, you want to use the one that starts with A or ends with A. So in a second here, we're going to be solving for one of our sides, and we're going to use that to determine which of these three versions that we're going to do. I am going to point out as we go along, there's one like super common error, and we'll mess around with that in a second. So let's do an example here together. So it's going to say something, your homework will say, find AB if AC is equal to 18 and BC is equal to 28, and the measure of angle C is 130 degrees. So AC is 18, BC is 28, angle C is 130. So we're going to sketch this to start off with. And this question just came up a minute ago. Does it matter where we put A, B, and C? It does not. I'm going to go ahead and do A, B, C like this, but if you want to change it, that's fine. And let's get this information in here. So let's go ahead also while we're here and let's label the sides with lowercase letters. So this would be little c, little a, and little b. That's going to help us when we're choosing our equations. And let's get our information on here. So angle C is 130. AC is right here. This is 18. So little b would be 18. And BC is 28. So thinking back to geometry, which of our congruence reasons could we use here? This looks like side angle side to me, right? And that's kind of a clue that we can use law of cosines. They're asking us to solve for AB. They're asking us to solve for that value, the value of C. So angle C is 130. So we've got angle C, but they're asking us to solve for little c. They're asking us to solve for side AB, which would be little c. A lot of letters here. Are we feeling okay about what they're asking us to do? All right, so I know from experience that if we're solving for C, we want to use the version of law of cosines that starts with C. And that is C squared equals, and I write this down every time because it helps me memorize it. I'm not making you guys memorize it, so maybe you won't, but I'm going to go ahead and do it since it's our notes. So because we're solving for C, I'm going to choose that version. So let's fill in values. So A was 28, B was 18, A was 28, B was 18, angle C was 130. So I'm just filling in the values from my triangle, and it's a lot easier for me to do because I did label the sides with lowercase a, b, c. So it's easier to match up those values. I see a couple people getting their calculators out. We're about to use those. We're trying to get C by itself. Isn't it wonderful that C is already almost by itself in this problem? What would you do to both sides of this equation to solve it? Square root it. So I'm going to just go ahead and do that right now. And I'm just going to type this big old mess into the calculator all at once with the square root. And that's it. We'll be done. So it looks kind of messy. Yeah, that's it. That's it. Of course, it gets a little bit tougher than that in a second, but not much. So 28 squared plus 18 squared. I'm putting all of this into a square root. -2 times 28 times 18 times cosine 130. And the parentheses for the square roots. Double check that I typed everything in correctly. Ooh, thank you for reminding me. Yes, we want to be in degree mode because that's 130 degrees, not 130 radians, and I was. And there we go. Let's round to, what does it say on your homework sheet? 10ths, so 1 decimal place. So C is about 41.9. And that would not be degrees because we're talking about the length of a side. That's it. What do you think? Pretty awesome. That's it. So go ahead. Let's do one on your own here. So why don't we do number 1 from the law of cosines practice? I want everybody to give this a shot here. And I think it's smart. They didn't do this, but I think it's smart before you get started to go ahead and label your sides, little a, little b, little c. So little a would be the 19, the 16's across from little b. We don't know little c. But we're trying to find AB, which is little c. So we're trying to solve for little c again. Set up your equation. I'd encourage you to actually write out the letter form at first. Since we're solving for little c, write down the version that starts with c. Get your values in there and get an answer. And I'll write up here what the answer is you're hoping to get, maybe. Uh-oh, did I pass that sheet out? Where'd it go? Did someone get my answer sheet? I guess I'll have to make my answer myself. Okay. So I'm going to go ahead and model what I expect to see work-wise because we've had some questions about this in the past, okay? You don't have to write this piece out, but on a test or on your homework, I do want to see that you've written out. You can't just go straight to the calculator, which I was about to do. Oh, I'm running into my other one. So I want to see that you've written it out with the 16 and the 19 and the 124 in there. And that is a terrible mess, but sorry about that. How's that look? Anybody can confirm about 30.9? Sweet. Almost 31. Uh-oh. What did I do wrong? $30.9. Okay, good. All right. So they're not all like this. Okay. I told you there are kind of 2 methods for solving these. We did the kind of more straightforward one first. So that's when you've got side angle side. When we get down to number 5, it's going to be a little bit different. What do you notice different about number 5? all we have are sides. We got side, 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 and we're solving for an angle. So the process is going to be a little bit different. And this is where the mistakes happen. So stick with me here as we go over this. And then I want to show you the classic mistake. So I'm going to do an example for our notes. Switch back over to your notes, please. So we're looking for a measure of angle A. AB is 21. BC is 13. AC is 29. (21, 13, and 29). Now it is, you can, with these ones, they can give you stuff that are not possible. Do you guys remember how to check and make sure that you can actually build a triangle out of 3 values? All sides have to add up to be something bigger than the largest side. The 2 small sides have to be bigger when you combine them together than the larger side. If you think about it, if I've got a side that's like this and the other 2 sides aren't at least as long as that, they're never going to meet up, right? They're going to be like, I can't try and stretch. So these smaller sides have to add up to be bigger than this, or else they're never going to meet up with each other. All right, and that's happening here, right? So keep an eye out for that, because you will run into one maybe on the sheet where that doesn't work, and you can just immediately say not possible, no such triangle, no work necessary. And I'm pretty sure if that ever does happen and you try and use law of cosines, you'll end up getting an error in your calculator. Well, I can tell because these all have numbers. And now I wouldn't have been able to tell on the last example. These will always work. If you have side angle side, there's no way they can give you information that doesn't make a triangle. They'll always work. Side, 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 the only way they could do it is if like if this had been a 5 instead of a 21, 5 plus 13, that's not big enough to stretch and cover that 29. So then we would just say not possible. This one will work though. Okay. Let's do this. Let's sketch our triangle. And again, I think it's smart to label all of the angles and all of the sides, because that's going to help us get our stuff in the right place. And then I'll go back and put our information in. We're solving for angle A right here. AB is 21. BC is 13. AC. So side, side, side. I know I'm going to use law of cosines. Which version though? Yeah. We're solving for A. We want the version that has A at the beginning. So can you put that phone away, please? Thank you. A squared equals B squared plus C squared minus 2AB. Oh, 2BC cosine theta. 2BC cosine A. Okay, here we go. We don't know A, but we've got A, B, and C, so we can start plugging some numbers in. So A is 13. B is 29. C is 21. 2 times B is 29 again, times C is 21 again, cosine A. And this is right The next step is where the big mistake happens. Oh my gosh, it happens so much. The next step is where I have students who will reach for their calculator and they are going to want to try and put all this stuff in here, except for the cosine. They want to put all this stuff into their calculator all at one time. It's so tempting, isn't it? You could turn, what if you could just turn that whole thing into one number, right? And if that cosine weren't sitting there, you could totally do that. How many terms are there on the right-hand side of this equation? Terms are separated by pluses and minuses. You see 3 terms. Are they all like terms? No, the first 2 are like terms. You could absolutely punch 29 squared plus 21 squared into your calculator and turn that into a single number. Absolutely. But you cannot include this stuff because this stuff's attached to a cosine and this stuff is not. All right, but you see how tempting that would be? Like, oh, that's all these numbers are super messy. Let's turn it all into one number. We can't. So, so here's what I'm going to do. I'm going to do 13 squared. Y'all know what 13 squared is? 169 equals, I don't know what 29 squared plus 21 squared is. I'll let my calculator figure that out for me. 1282. Did you do that in your head? No. Okay. That'd be awesome. Me too. And then why don't we put 2 times 29 times 21 in our calculator? We can put it in separately. This is all attached, right, by multiplication. So we can keep that. What are we going to do next? Eventually, we are going to do an inverse cosine. We need to get the cosine by itself first. I would probably, you could do it that way. I would probably get rid of this. I would subtract this from both sides and then I would divide by this. So what is 169 minus 1282? You know what, since this is our notes, it would probably be smart for me to actually write out what I'm doing here, right? Minus 1282, minus 1282. In a homework assignment, I probably would not write this step. Go ahead and make myself a little note of where all this stuff's coming from too. And then divide. Cancel it. And I would just leave this as a fraction. I'm not going to actually type that into my calculator because I don't want to round off in the middle of the problem. Those negatives would cancel though, wouldn't they? And then wrap it up by doing an inverse cosine. Both sides. Those would cancel there. And then we're just using our calculator from there. My calculator, go ahead and type the inverse cosine in your calculator and make sure you're getting the same answer. If we're going 1 decimal place, this is going to come out to 24.0. Of the fraction, yeah, inverse cosine of the fraction. Yes. Keep it to variables until the very last step. Yeah, so I was just about to say that, so thank you for the question. Keep it to variables till the last step or keep it as the original value? So if I were doing this, I probably wouldn't type anything into my calculator until the very last step. So I would probably do this a little bit differently. It looks a little bit messier, but every time you got to stop and type stuff in your calculator, it slows you down. So if I were doing this, I'm going to go back to this step right here. 13 squared equals, thank you. I think this is what you meant, maybe? Or were you going to solve it with A's and B's and C's? Well, you could do that. And then what you do then is you've created a general form for the solution and you don't have to do all these steps anymore. If I were doing this problem, it would look like this. I would say this would become 13 squared minus 29 squared minus 21 squared equals 2 times 29 times 21 cosine A. And then this stuff would all end up over top of 2 times 29 times 21. And then I would just do an inverse cosine on this whole thing. That would be the work that I would show. And I would just type that all in the calculator at the same time. You got to be careful though, because I'm going to need parentheses around my numerator and my denominator. So it looks a little bit messier, but it's faster for me. Let's make sure I get the same answer though. Oh, I didn't want 21 squared, did I? But I missed some stuff. It's 2. Oh, it should have been 21 squared. 13 squared minus 29 squared minus 21 squared. 2 times 29 times 21. Okay, maybe this doesn't work. Oh, it was negative. I lost my negative sign right here. There we go. Yeah, I missed my negative sign. However you want to do it. All right, what you got to be careful of though is this. Can you guys look at this really quickly? So here's an equation. And I just took this whole big old mess and stuck it in the calculator and called it 64. You can't do that, okay? Watch out for that. And if you try and do that, then you end up with an error. You're not always going to get an error when you make that mistake though. A lot of times you will, but you won't always. All right, can I get you guys to try number 5 right now? On your homework? Yeah. Let's give it a shot right now. Ask me some questions if you've got questions. I'll get you an answer here so you can check. I do want you to at least write it out with the numbers before you solve it. Don't just type it straight in the calculator. But that's what I'm going to do. Question? Oh, there's copies right here. If you want to grab them. I'm sorry. What time did we end today? 12:15. 12:15. That's it. I can add some more if you want. Sure. I don't want to make your spring break super boring. The review is not due when you get back, but yeah, it would be smart to get started on it. Huh. This one comes out confirmed. Yeah. Should be looking at about 38. Let me know if you have any questions. You're welcome to keep working. I want to show you one more quick thing once everybody's done here. But if you want to just keep at it once you've gotten 38 for your answer, that's totally fine by me. This last thing is pretty cool though. Yeah, I think I'll have time today. All right, hey, let me show you one last thing here, okay? This is really cool. You don't want to miss this. All right. Let me write out law of cosines, one version of the equation. C squared equals a squared plus b squared minus 2ab cosine. This would be a c, correct? What happens to this equation if we deal with our right triangle? Oh, don't miss this. This is really cool. Hang on. I'll help you in a second. Pay attention. Pay attention. Don't miss this, okay? If this is a right triangle where this is C and this is A and this is B, then this would be side C, this would be side A and side B. Agreed? If C is a right angle, then we're taking the cosine of 90. What is the cosine of 90? You're right. This would be the B and this would be. What is the cosine of 90? The cosine of 90 is 0. So this entire term is going to go away, right? If the cosine is 90. And what do we have when that whole term goes away? It's good old Pythagorean theorem. So the Pythagorean theorem is actually just a simplified case of the law of cosines. Law of cosines works for any triangle. The Pythagorean theorem is a specialized version where if you have that 90-degree angle, it causes all this mess out here to drop off. Isn't that cool? All right. You guys got time, and I got time to check your homework. Woo! All right. We all win. Thank you for your attention.